Hello, good morning, good afternoon, good evening. A very big welcome to all of you to Coffee Class. I go by the name Agbo Makafui, and this is my YouTube class. Alright, so in today's lesson in core mathematics, we want to look at simultaneous equations. Simultaneous equations in mathematics simply has to do with working with two or more equations at the same time. Working with two or more than two equations at the same time. You can have a situation where you'll be working with three equations. You can have a situation where you'll be working with four equations. Or you can have a situation where you are going to work with only two equations. That is what is meant by the simultaneous equation. And mind you, you'll be working with those equations at the same time. So you work this at the right side, you work this at the left side. So you are working, hand in hand. That is meant by the simultaneous equations in mathematics. Okay. Now let's look at an example of the simultaneous equation. So I have x plus y is equal to 3 and then 2x plus y is equal to 5. Equation 1, equation 2. We can see that they are supposed to be happening at the same time, and that is what we see. Now how do we work this out? There are some ways or methods that we use in solving this one, and that is what I want us to focus on today. So with the methods of solving, we have the elimination method, we have the substitution method, we also have the graphical method, and then finally we have the calculator as well. So either you are going to use the elimination method, or you use the substitution method, or you use the graphical, or finally the calculator. But most of the times we don't advise you to use calculator. We want you to work it out so that when it is a theory question, you'll be able to get it right. But if it is objectives, you can just punch it on the calculator, you get your answer right, and then you are gone. But what if it is not an objective question, but it happens to be a theory question? How do you go about it? All right. So let's take our time then um, digest what we have on the board. So with the elimination method, we are interested in eliminating the variable which we don't want to be in the equation at that time. So it is one of the methods which is going to take out one of the variables and then leave only one particular variable, making it a linear equation in one variable. All right. So that is it for the elimination method. A bit about it. And then don't forget that under the elimination methods, we have some types. We have three types of the elimination method as well. The first type has to do with the coefficient of the variable you want to eliminate having the same coefficient, that is equal coefficient. And the second type has to do with multiplication by a constant. And the last one has to do with uncommon coefficient. So we are going to take our time and then go through the types carefully and then see how far we can move with these simultaneous equations. So with the equal coefficients, I have 3m plus 2n is equal to 16. 5m plus 2n is equal to 20. We can see clearly from here that there is 2n here, there is 2n here, which means that the coefficients of n in equation 1 and equation 2 are equal. And this is what the equal coefficient is talking about. So with this one, we now consider the operation sign in front of the coefficient. There is plus here, there is plus here. If you have the same coefficient, the same operation in front of the coefficient, then it is very good if you if you subtract the two of them. If the operations are the same, subtract them. If the operations are different, then you can add them now. So we subtract equation 1 from 2 since equation 2 is less than equation 1. 5 minus 3, that gives us 2. 2 minus 2 is 0. 20 minus 16, 4. 2m is equal to 4. Divide through by. So I'm dividing through by 2. And then that gives me m is equal to 2. Like this. M is equal to 2. Okay. So since m is equal to 2, I have to find the value of n. So I'm putting m is equal to 2 into equation 1. And then that gives me 3 times 2, 6, plus 2n is equal to 16. 10 divided by 2, that gives me 5. So we say therefore m is equal to 2 and n is equal to 5, right? So I'm going to give you one example and then you also try for me. When you get the answer, put it in the comment section. And if you are right, you get something. If you are not right, you can learn from your mistakes. All right. Yeah, so I have one beautiful question for you to try at your um, free period. When you get it, let me know so that we see how far we can move from there too. Okay. Now let's look at the type 2, which is the so type 2 brings us to the multiplication by a constant. Multiplication by a constant. So with the multiplication by a constant, we now look at the coefficient of the variable we want to eliminate. Is the smaller one a factor of the bigger one? If yes, then we can multiply the smaller one by a constant, and then that gives us the same value as the bigger one. And if we do that, we have the same. We now come to the equal one. Then from the equal, we can eliminate using the either the plus or the minus, either the subtraction or the addition process. Okay. So under the multiplication by a constant, let me take one quick example and then we proceed from there. Now when we check this carefully, we see 4a here, we see 4b, we see 36, we see 6a, we see minus 2b. 4 and 6, 4 is not a factor of 6, neither is 6 a factor of 4. But when we consider 4 and 2, we can see that 2 is a factor of 4. So what do we do then? We now have to get a constant to multiply the 2, which will give us this 4, so that we can be able to eliminate these 2 now. Do you get it? Alright. So what constant do you think we have to use? So we have to multiply the 2 over here by 2. And if you want to do something, it is going to affect the whole equation too. So we say that multiply equation 2 by 2. So by this statement, we mean that the 6 here should be multiplied by 2, the 2 by 2, the 22 also by 2. If that is the case, I have 2 times 6a minus 2 times 2b is equal to 22 times 2. 2 times 6, that is 12. So 12a minus 2 times 2 minus 4b is equal to 22 times 2, 44. Now we can name this as equation 3. Now we have 12a, we have 4b, we have 4b in equation 1. If that is the case, we can now work with equation 1 and equation 3. Instead of equation 1 and 2, we can now work with equation 1 and equation 3. And that is going to make our work kind of easy for us. So let me clean the other part and then we continue from here. Now we can see that the operation sign in equation 1 of the 4b is plus, and that of the 4 in equation 2 is negative. So since the operation signs are different, then we have to add the two of them so that we can now get this term be given as 0. Then we can work with only the a. So we add 12 plus 6, 12, 4 plus 12, sorry, 4 plus 12, that should give us 16a. And then negative 4, 4 plus minus 4, that will be 4 minus 4, giving us 0. Then 36 plus 44, that should give us 80. 16a is equal to 80. Divide here by 16, here by 16. A is equal to 5. Now we put a is equal to 5 into any of the equations, either equation 1 or 2. So I like to put this into equation 1. So it's in equation 1. That will give us 4 into bracket 5 plus 4b should give us 36. 4, 5, 20 plus 4b is equal to 36. 4b is equal to 36 minus 20. Please do you get it? So 4b is equal to 36 minus 20. 4b is now equal to 16. Divide through by 4. Divide through by 4. b is equal to 4. So we say that therefore a is equal to 5 and then b is equal to 4. Is that right? Okay. So as usual, I solve one, I give one example. So you let me know what you had in the comment section or come into my DM with the number you see on my screen, and then from there we can continue. Okay. Alright, so remember that this thing, it is the type 2 example, which is the multiplication by a constant. So you look out for a constant that you can use to multiply any of the terms, which will give you another number which is already there. That is what we want to do. Okay. So let's quickly look at the last type under the elimination method, which is the uncommon coefficient. And then from there we can maybe draw the curtains on this session. Then with time I'll bring you the continuation of this particular simultaneous equation lessons, starting with the substitution method, as we stated on the fourth under the methods of solving the simultaneous equations. Alright, so we have 2b plus c is equal to 10. 3b plus c is equal to 10. Sorry, I beg your pardon. 3b plus c is equal to 10, and then 2b plus 2c is equal to 4. So we can see that there's nothing common over here that we can be like when we do this, you get it. But all the same, it is not something difficult. You just have to be intentional and then listen to the instruction which comes with some of these things, and then you'll be able to get it from there. All right. So what we are going to do over here is to ask yourself, can I multiply this the whole of equation 1 by a constant, and then maybe multiply equation 2 also by a different constant, so that one of the variables here will be easy to eliminate? Yes, the answer is very simple. When we look at the c over here, it is 1, and then here is 2. Then it means that if I multiply here by 2, I'll get a 2 here, and then I multiply this 2 by 1, I'll get 1, because the coefficient of c over here is 1. So I use the 1 to multiply the c here, giving me 1, and then use the 2 here to multiply the coefficient here, giving me 2c. So multiply equation 1 by 2. 2 by 3b plus 2 by c is equal to 10 by 2. 2 by 3b, that's 6b, plus 2 times c, 2c is equal to 20.